Okay, so we want to continue our conversation with normal distributions. And so we're given an example now where a patient with a mean systolic blood pressure of 120 millimeters of mercury, if we were to kind of consider that as their mean, the standard deviation is about 11.9. So that's how, if they were to kind of take different samples of their own blood pressure, that's what we would expect the variation to be, about 11.9. And so our parameters in this situation for an individual, the mean of their blood pressure is 120 and the standard deviation is 11.9. Depending on when they take it, there's a little bit of variation. So we can approximate this with a normal distribution, and I've already gone ahead and labeled this bell curve. So we know the mean is in the middle. Just a quick review. And I've already labeled one standard deviation above, two above, three above by adding the different sides of the standard deviation. And I also subtracted a standard deviation, subtracted 2, subtracted 3. And you can see, similar to what we've already seen in this module, is that the further away you get, the more unlikely a particular outcome is. And so most values in a normal distribution on this bell curve lie within one standard deviation, lie within 2. It's within that group there. We did the 68, 95, 99.7 rule. The further away you get, the less common those observations are. And we calculated percentages. If it has this bell curve shape, we were actually able to, as I said before, look at that 68, the 68 rule, the 95, 99.7, and we saw that there are individual percentages associated with each of these sectors. So this was 13.5% is within the mean and negative 1 standard deviation, and 13.5% is within the mean and 1 standard deviation above. And if we saw an observation that lied perfectly, like if I said what percent lies between 108.1 and 131.9, we know that's about 68% because it lined perfect with these standard deviations. But that's not always going to happen. So what if I asked about a different value that lied between standard deviations, and I wanted to know the percent that was above 140 or the percent that were below 106? These aren't lining up perfectly with our standard deviations, so we're going to need to use a calculator to help us. And that's what we're going to do now. So if I consider this same situation, but what I want to do now is I want to consider the percent, and sometimes it'll be framed as a probability. What percent or probability of blood pressure measurements would we expect to be less than 140? And so again, I'm just going to very quickly draw a picture here. I know that 120 is in the middle. My mean is 120. My standard deviation was 11.9. And I saw on my last page here that 140 or below. So if I look here, 140 is a little bit below this second standard deviation above. And so on my picture, this is about where 140 is. And I want to know what is this percent. So I'm going to shade to the left of that value because I'm asked to find the percentage that would be less than 140. So immediately, even before I do any calculations, I see it's definitely greater than 50%. More than half of the area is shaded. But we want to go to the web app that is linked in our module, and it is the normal distribution web app, and we're going to plug in all these values. And so if we click on the link, it'll take us to this explore page. But what we want to do is to find a probability. So I'm going to go ahead and click up at the top to find the probability. I know what my mean is. The mean is 120. The standard deviation is 11.9, and the picture will change as you enter your values. And we're looking for a lower tail because we want to know the values that are less than. The upper tail would be considering the values or the area above our observation. So let's look at the lower tail, and we want to know our value of x is 140. So we're looking for the area below 140, and if we see this is exactly what our picture looked like when we sketched it. We have the mean here in the middle, we had 140, and we can see it's shaded to the left. And it's telling us based on this picture, and I'm going to label this on mine, and then I will come back to the original slide. But I see that 95.36% is below, and it gives you also the above. So 4.64, that means is above. And you can see they add up to 100%. So what I was looking for was the percent, or the area that's below this value of 140. And I got it to be 95.36%. And that's what we see here. So 95.36% of measurements, we would expect them to be below 140. So that's what we would expect. And I just plugged in the mean, plugged in my standard deviation. I was looking for my observation of 140, and this is a lower tail because I'm looking below, a lower or below, and that's not the upper tail. The upper tail would be if you're looking for above the observation. We can also consider values that are between, and we'll consider that in a moment. But let's look at the next example. Now we want to look at the same situation. So we know the mean. We know the mean is 120. We took 85 measurements over a 3-day period, and we want to know how many of these measurements would we expect to be greater than 108. So I'm going to put 108 on my picture here, and 108 is going to align. If I look just back very briefly, 108 is going to be, it's very close. It's not exactly, but it's very close to the -1. So it's a little bit above by 0.1. So I'm going to go ahead and label that on my picture. So 108 is very close to this value. 108 is about here. And I want to know the percent that's greater than. So I'm looking for this area here. Looking for that area. And so that means I'm looking for an upper tail because I'm looking above the value. And so I'm just going to go back to the app and plug these in. So I have the mean, the standard deviation. I'm looking for an upper tail. And again, it'll change a couple times. I'm going to put in 108. 108. It'll automatically update. And we get that 84.34% is our approximation. So 84.34% of values are going to occur. We'd expect them to be above 108. So again, I'm looking at the area that's above, and that's this darker part here, 84.34%. So we would expect that 84.34%, but now we want to consider the value. That's the percent. So I want to know, well, what is that out of 85? So I'm looking for 84.34% of those observations, so of 85 measurements. So we're going to take our percent times our value here. So as a percent, that as a decimal, it's 8434. We'll multiply that times the 85 measurements, and we'll get an approximation of about how many of them would be above this 108. So in my calculator, 0.8434 times 85, you get approximately 71.689. And if we round to the nearest whole number, because we're talking about individual measurements, we get about 72. So we would expect out of those 85, about 72 of them to be above 108. Notice what we had to do here is we had to first calculate the percent with our calculator, and then we brought the percent into the problem to calculate the number of measurements. We now have one more example where we're going to consider an interval. And this is going to be very similar to what we've been doing in the last two slides, but on the calculator, we're going to select that interval option. If you want to pause the video now to try to label your picture, plug them into the calculator and see what you get. We're looking for the percent of values between 108 and 125, and then using that percent to figure out how many measurements out of 85 we'd expect. I'm going to go ahead and continue here. We knew that 108 was right about there. 120 is the mean, and 125 is going to be 5 above the mean. So that's going to be 125. And I want to know the percent of observations or measurements that are between these values. I already know my mean is 120. I know my standard deviation is the same, 11.9. So we're going to find this percent. What is this percent? That's what we have to find first. So let's go ahead to our normal distribution calculator. We already have our mean and standard deviation. That's going to change when you're doing your homework or on a quiz. You're going to want to adjust those for the particular parameters of the problem. We are looking at an interval. We're looking at a between calculation. And we want to know the values between 108. So I'll put 108 as my lower value for A. And my value for B is 125. And you will see that it matches the picture that we drew. It matches exactly the picture that we drew. So it's really important, and I encourage you to draw, just sketch a picture to help you before you use the calculator, because then you can confirm, yep, that's the picture that I had. And so I see that this area here, this is 50.62%. So we expect 50.62% of measurements to be between those values. And so 50.62% is the percent. And now if we took 85 measurements, then we know about half of them, so about 50.62% of 85 measurements. That's what we want to know, about how many of these are going to be between those values. So I'll take my decimal equivalent of that percent, I'll multiply it by 85, a good review of what we've been doing this semester. So 0.5062 times 85. We get approximately 43.027. Actually, it's equal to exactly that, which if we round to the nearest whole number would be about 43 measurements. So given what we know about this normal distribution, if we know this variable, in this case, the systolic blood pressure, if we know that this has a normal distribution and we know the parameters, we can take some pretty accurate estimates to calculate, well, out of 85 measurements, we would expect about 43 of them to be between 108 and 125. And so knowing that it has this bell curve really allows us to dig into the calculations, tells us quite a lot about these values so that we can estimate percents and individual measurements in this case and other values associated with that variable.